All right. Wanted to make a video regarding measuring input and output efficiency and all that. And I got to thinking about it. Maybe I'm just having a brain fart, but seems like nowadays a lot of times, people are totally fine with measuring their efficiency by simply taking a ammeter, putting it in line with the input. Likewise, putting an ammeter in line with a load on the output. And I noticed that every time I do that, I'm always pretty confident at the numbers that I'm seeing. But sometimes when I use loads in place of the meters to get an idea of what's going on, I seem to get a little confused at what I'm seeing. So in this example, I just basically have a joule thief using the existing transformer. Nothing complicated here. All I've got is 2N3055, some different resistors in series, and a 5K pot. And what I have here is two identical 12-volt auto bulbs. They're the small ones. And they came out the same pack. I'm just going to assume they're the same. I can swap them back and forth and still get the same results. But here I have a 12-volt input to the circuit, and that is actually in series with this bulb. So the bulb is in series with the input, and I've got the identical bulb here as my load across the output, opposed to DC output. And these are basically exactly where the meters would be in the same situation. So let's just cut it on. Now the way that I have the circuit tuned right now, I've got it on a very low resistance. The circuit is pretty much consuming the maximum that it will consume. And what you see across the bulbs is what you would expect to see. The bulb that is in line with the input, technically speaking, is showing you the current that the circuit is consuming. That's what you would, that's what I'm led to believe. Or you want to think that is the case. The actual heat that you see dissipating here could be indicative of the actual current that's going through the circuit. That's what you're supposed to think. That's what the meter would say. Likewise, this bulb across the output here is barely lit. So you can see from the difference, this is not a very high efficiency. I'm getting less than half of what I'm putting in. Okay. Now, it can be tuned. For example, if my meters were in place of the bulbs, I would imagine it would be saying something along the lines of I'm pulling maybe 80 milliamps, and I'm getting out maybe 30, 20, something like that. So if I tune it down a little bit, I can get my input to go down, but you can see my output bulb does not change in brightness. So you could technically say this whole adjustment I'm doing right here does not do anything but decrease the amount of current that's being wasted in the circuit. So at this point, it's very hard to tell the difference between the input and output bulbs. I almost want to say the output bulb is brighter, but for the sake of this argument, let's just say they're the same. So technically speaking, what I would be looking at now is I would consider, I'm not going to say 100% efficiency, but you could just say what is going through the front of the circuit is the same thing as what's coming out the back of the circuit. Now, I'm not sure efficiency-wise what to call that. Either way, nothing very mind-blowing or strange. So let's try some different resistances. Let's kick it up a little bit. Kick up the resistance to the point where the circuit is hardly drawing or outputting anything. And as it stands, the output bulb is barely red, input bulb showing nothing. Let me see if I can turn it up a little bit. Turn it up a little bit more, my output bulb gets a little bit redder, a little more current going through it, but yet still nothing. I'm seeing nothing across the input bulb. So here's a situation where I'm supposed to be seeing the amount of current that's going into the circuit to provide this amount of current, but I'm not seeing anything. So I'm not sure what to call that in that situation. Technically speaking, if these were meters, I would think this meter would be showing me a smaller amp draw than what this is showing across the load. Obviously, that's not the case. But using these bulbs, that's what you would be led to think. So you have to assume, okay, well, just because I'm not seeing anything across this bulb doesn't mean that there's, not more current actually being consumed than what you see here. It has to be the case. Same thing if I increase the resistance some more. That bulb is going to be even less lit, of course. But I'm still seeing the filament red as opposed to not seeing anything in the input. So that is just a simple experiment of how maybe we're not exactly getting a good reference of the current we're seeing in our meters. We're not always exactly getting an accurate reference of what's really going on, I would have to say, because in this situation, if I were just to visually reference these two bulbs, I would have to assume that the amount of current that's traversing through this filament is a smaller amount than what is traversing this filament. Now, as far as power total, we can't assume that's the case, because that would be defying the laws of physics. So we have to wonder what is really going on. Why is this filament not lighting, and why is this one lighting? These are both 12-volt bulbs. You could try to argue that, well, maybe the very low voltage or very high voltage across this bulb is what's lighting it, as opposed to the 12 volts that's hitting this bulb. Maybe this one just wants to light easier. I find that hard to believe, considering all it takes is 12 volts, a very few milliamp, to light this bulb. So why is it not lit when the circuit should clearly be consuming more than what you see here? So you have to wonder, if the circuit itself is consuming more energy total than what is dissipating across this bulb, then why is this not lit? Very simple question. I'm sure there's a very simple answer, but regardless, it has me doing this on all my circuits, and pretty much all of them have the ability to tune, so I see light across the output and no light across the input. And it seems to be more efficient the higher you go in resistance. For example, let's go back down to the low resistance where this circuit actually puts out a decent amount. That's the best I can tune it. They're about the same brightness. But if I tune it anywhere out of that region, my input just increases to go up, and my output does not increase with it. So this is what you would expect to see normally. This is what you might want to see and be kind of happy about. And this is just what doesn't make sense to me at all. And you start to see, turn my circuit on. When you start to see your output bulb being lit and nothing across your input, that's what starts to be a little confusing. But alright, that's all I wanted to show.